Hello guys, my name is Prince and this is Math Center. Subscribe to my YouTube channel for more videos. Post your comments and questions on my social media handles and I'll respond to it. We are still on the topic plane geometry. In the previous video, we learned how to find the angles in a triangle using the properties of a triangle. In this video, we are going to learn the angle properties of a quadrilateral and pick some examples on how we can use these properties to find angles in a quadrilateral. So what is a quadrilateral? A quadrilateral is a plane figure with four sides. In the previous video, we said that a triangle is a plane figure with three sides. So any plane figure with four sides is called a quadrilateral, just as any plane figure with three sides is called a triangle. I hope that is clear. So a plane figure with three sides is a triangle. A plane figure with four sides is a quadrilateral. If you watch the video on mensuration, we considered different types of quadrilaterals: squares, kites, rhombus, and we looked at the properties of these. In this video, we are going to consider the angle properties of a quadrilateral as a whole. That's what we are going to consider. So let's say we have this quadrilateral here. We have this four-sided plane figure. So PQRS is a quadrilateral. Now, what are the angle properties of this quadrilateral? The main thing you have to know about quadrilaterals is that the sum of the interior angles of a quadrilateral is 360 degrees. In the previous video on triangles, we said that the sum of the interior angles of a triangle is 180 degrees. For a quadrilateral, if you sum the interior angles, you are supposed to get 360 degrees. So what this means is that, let's say I call this angle here angle A. I call this one here angle B. I call this one here angle C. And call this one here angle D. The sum of the interior angles of a quadrilateral is equal to 360 degrees. What this means is that A plus B plus C plus D will give us 360 degrees. This is the main property of angles in a quadrilateral. Now, let's pick some examples and see how we can use these properties to solve some questions. So let's pick the first one. Find the value of the letter in the following diagrams. So with this diagram, we are supposed to find the value of S here. Now, what do we know about this? So this is going to be the solution, not the question. So I'm going to cancel this here. Okay, so this is the solution. The question was what we had on the previous page. So let's begin with the solution. We know that the sum of the interior angles of a quadrilateral is 360 degrees. So if we add all the angles in this quadrilateral, you should get 360 degrees. So S plus 140 degrees plus 70 degrees plus 65 degrees will give us 360 degrees. We do this simplification and S will give us 85 degrees. So as soon as you write this, the rest is linear equation. You add the numbers, then you make S the subject. We do that and we are getting S to be 85 degrees. So we have used this property of a triangle, of a quadrilateral, to find the value of S. Let's consider the next question. So here we are finding the value of S. Now we know that the sum of the interior angles of a quadrilateral is 360 degrees. So what this means is that if we add 2S to S to S plus 10 to S minus 50, we are supposed to get 360 degrees. So we add everything, all the interior angles of the quadrilateral, and we equate that to 360 degrees. So S plus S plus 2S plus S plus S plus S will give us 5S. 10 degrees minus 50 degrees will give us minus 40 degrees. Then we equate this to 360 degrees. So we are going to get 5S is equal to 360 plus 40 degrees. So 5S will equal to 400 degrees. We divide both sides by 5 and we are getting S to be 80 degrees. So we have S to be 80 degrees. So we know that the interior angles of a quadrilateral add up to 360 degrees. So we add all the interior angles and we equate it to 360 degrees. Let's consider the next example. Now we have this quadrilateral here So this is the quadrilateral, and we are supposed to find the value of S and Y. You are supposed to find the value of S and Y. Now, we can see from here that there are two isosceles triangles in this quadrilateral. So if you take the triangle PON, it's isosceles because we have this bar here and this bar here, showing that the length of PO and the length of NO are equal. So if this angle here is S, then this side here will be S. That is why the point here is telling us that then angle PNO, so PNO, which is this angle here, is equal to angle NPO, which is this angle here. So because triangle PON is an isosceles triangle, if this angle here is S, then here must also be S. I hope that is clear. Even though this is a quadrilateral, the question has divided it into two triangles for us, and we are seeing that one of the triangle here, angle PON, is an isosceles triangle. So we can use the properties of isosceles triangles to find the value. So just as I said, whenever the question is given to you, study the diagram very carefully. Then the properties that we've learned, look at the one that applies to the question that has been given to you, then you use it. So here we have seen that triangle PON is an isosceles triangle. We know the properties of isosceles triangle. Two sides are equal, and the angles formed at the base of those two sides are also equal. So if this place is S, because PON is an isosceles triangle, this angle will also be S. I hope that is clear. So we have S here, we have X here, we have 70 degrees. PON is a triangle, so we can use the properties of interior angles of a triangle to find the value of S. We know that the interior angles of a triangle sum up to 180 degrees. What this means is that S plus 70 degrees will give us 180 degrees. S plus S is 2S plus 70 degrees is equal to 180 degrees. We simplify this, we are getting 2S is equal to 110 degrees. You divide both sides by 2, and S is giving us 55 degrees. S is giving us 55 degrees. So we found the value of S. Now let's move on to Y. Now consider the triangle PMN. Look at it very well. Let's consider triangle PMN. Now you can also see that triangle PMN is also an isosceles triangle. We have two bars here, then we also have two bars here, showing that the length of the length of MP and the length of MN are equal. So there are two bars here, then there are two bars here, indicating that the length of MP and the length of MN are equal. So if two sides of a triangle are equal, it means that the triangle is an isosceles triangle. And because triangle MPN is an isosceles triangle, the angle formed at their bases will also be the same. So the angle formed at Y and the angle formed at 65 degrees will be the same. So if here is 65 degrees, then it means that Y is also 65 degrees, because triangle PMN or triangle MPN is an isosceles triangle. The angle formed here and the angle formed here will be the same. So Y is equal to 65 degrees. So angle MPN, so MPN, which is Y, is equal to angle PNM, which is 65 degrees, because triangle PMN is an isosceles triangle. I hope that is clear. So we have found the value of X, we found the value of Y. We have another letter here, which is Z. Now how do we find the value of Z? Let's look at this very carefully and consider triangle PMN again. We see that Z here is an exterior angle. If you look at it very well, you will see that Y and 65 degrees are the interior opposite angles of this exterior angle, which is Z. What do you know about an interior opposite angle of a triangle? We know that an exterior angle of a triangle is equal to the sum of its interior opposite angles. We have an exterior angle here, which is Z. We know its interior opposite angles to be Y and 65 degrees. We found the value of Y, so we can find Z from there. What this means is that z or z is equal to y plus 65 degrees. We know that y is 65 degrees, so z is equal to 65 degrees plus 65 degrees, which will give us 130 degrees. This is one way of solving the question. Somebody can also choose another way of solving it. As I said, there can be so many ways of solving the question. The most important thing that you have to do is that you study the diagram very well, you record the properties that you've learned, then go through the properties and see which one will help you to solve the question. Then you use that property. Now we are going to consider this. We can see from here that in this quadrilateral A, B, C, D, we have some power lines here. So because we have power lines, we can use co-interior angles, we can use alternate angles, and we can use corresponding angles. Together with the other properties that we know, we can use all of them to solve the question here. So let's study the diagram very well. Now we are supposed to find x, we are supposed to find y, and we are supposed to find m. Now, which one do you want to start with? We know that alternate angles are equal. Now let's look at the diagram very well. This is a power line, BC is a power line, AD is also a power line. So it means that this line here, this diagonal here, if you watch the video on mensuration, you will see that this line is called a diagonal. Line AC is called a diagonal. If you look at this diagonal very well and look at the power line BC and power line AD, you can see that M and 40 degrees are alternate angles. Now look at it very well. This is the power line, this is the transversal, then this is the power line here. So the angle formed here and the angle formed here will be alternate angles. What do you know about alternate angles? We know that alternate angles are equal. So M is equal to 40 degrees. So we've used the property of alternate angles to find the value of M. Now let's look at the diagram also very well. We can also see that S here, this S here, and the angle that will be formed here are also alternate angles. So angle ACD, angle ACD, which is this small angle here, the small angle that we have here, is also equal to S, because if you look at it very well, this is a power line, this is a power line. Now considering this one too, AC is a power, DC is a power line, AB is a power line. So looking at this, this is the power line here, this one is the transversal, then this is the other power line. So the angle formed here and the angle formed here are equal because alternate angles are equal. So if here is S, this side here is also going to be S. So you see, you have to be conversant with the alternate angles, corresponding angles, co-interior angles, on all the other properties. You study the diagram and you see the one that will help you to solve. So here we are using alternate angles, and we have figured out that if here is S, then this side is also S because they are alternate angles. We have S, we have 120 degrees, we have 40 degrees. ADC is a triangle. We know that the sum of the interior angles of a triangle is 180 degrees. So we can add 40 to 120 degrees to S and equate it to 180 degrees so that you can find S. So S will give us, this is going to give us S plus 160 degrees is equal to 180 degrees. We simplify and S is giving us 20 degrees. So S is giving us 20 degrees. So we have S, we have M. We are now left with finding Y. Now, because we have S, we have M, if we want to find Y, we know that ABC is a triangle. The sum of the interior angles of a triangle add up to 180 degrees. So S plus M plus Y will give us 180 degrees. We know S to be 20 degrees. We know Y to be, we know M to be 40 degrees. So we add that to Y and we equate it to 180 degrees so that we'll be able to find Y. So we simplify this, we are going to get Y plus 60 degrees is equal to 180 degrees, and Y will give us 120 degrees. Y is giving us 120 degrees. So all that you need to do is to study the diagram, then apply the properties that you've learned. If you see power lines in the diagram, it means that you can use corresponding angles, alternate angles, co-interior angles, together with the other properties that you know to solve the question. This is one way of solving the question. You can also try to use another way to solve the question and see if you are going to get the solution or the answers that you got in this video. Thank you for watching this video. To understand this very well, pick more examples and try your hands on them. If you have any difficulty in solving the question, interact with me on my social media handles and I'll help you to solve it. See you in the next video, where we are going to consider the angle properties in a polygon. Bye bye.